All right, so today we're going to look at how to find the determinant of square matrices. That's the only type of matrices that have determinants, square matrices, so like 2 by 2s and 3 by 3s, 4 by 4s. So we're going to learn how to find, so first you can't do the determinant of a non-square matrix. So I'll never ask you to find the determinant of like a 1 by 4 or a 3 by 2. All right, and you could think of a determinant as just a number associated with a matrix that will help us do applications of matrices. So with determinants, we could find the area of a triangle, we could solve systems, we could solve matrix equations. Because in order to find the inverse of a matrix, we need to know how to find the determinant. So just sit back, and I hate teaching things without telling you why they're important, but we'll learn why these are important later. Today we're just going to focus on figuring out how to find the determinant of a matrix. So first on the top here, we have notation. So if you're ever asked to find the determinant of a matrix, it might be written like this, DET of A. And on the TI Inspire, which I'll show you how to use later with matrices and specifically determinants, you would just type in DET and then put in the matrix in between the parentheses, and it would find the determinant. Now, the determinant is just going to be a number. All right, sometimes it's 0, sometimes it's positive, sometimes it's negative. All right, but it's just a number. All right. It might also look like the second bullet, look like kind of like absolute values. So when you see these absolute value bars around the name of a matrix, it's just asking you to find the determinant of that matrix. So in the context of matrices, those two lines don't mean absolute value. It means determinant. Or they might just, instead of writing a matrix like normal, like this, they might put the matrix without these little orange parts, with just like two horizontal vertical lines. And that means find the determinant of that matrix. All right. So you could do it with a calculator or by hand. You're going to have to know how to do a determinant of a 2 by 2 by hand and with the calculator. For a 3 by 3, I'm going to show you how to find it by hand, but I'm fine with you using a calculator for that, unless you're specifically asked to find the determinant of a 3 by 3. So first, let's start with a 2 by 2. So it's pretty simple for a 2 by 2. Okay, it's just you're going to take these two numbers, A and B, you're going to multiply them together, and then you're going to take B and C and multiply these two numbers together. All right, and then subtract them. That's it. Now, A just refers to the number in the upper left of a 2 by 2 matrix. B is the number in the upper right. C would be here. D would be there. So A is first row, first column. B is first row, second column. C is second row, first column. D is second row, second column. And you do A times D minus B times C. So starting off with the basics here, if we were asked to find the determinants of these here, all right, so this first matrix, number 1, you would just do 6 times 3, so you'd get 18, and then subtract 2 times negative 1. So 18 minus negative 2 would be like 18 plus 2. So the determinant is 20 for that matrix. Okay, for number 2, you would do negative 1 times 4 and get negative 4 minus 5 times 3, 15. So we get negative 19. All right, so determinants could be positive, could be negative. So although they share a similar notation to absolute value, it's not like an absolute value where it's always positive. It could be positive or negative, or it could be 0, and we'll see what happens there. And actually, we'll see it right now. In number 3, all right, if we found the determinant of that, you would do negative 4 times 3 and get negative 12. And then you would do minus 6 times negative 2. So negative 12 minus negative 12 would be like negative 12 plus 12, and you get 0. All right, so determinants could also be 0. Now, that's going to happen when it has, I don't want to get too far ahead of myself, but if you ever notice that like one row is a multiple of another row, then the determinant is going to be 0. And we'll see why that makes sense when we learn about using determinants to solve systems. But for now, just apply the rule like A times D minus B times C. All right, so take a minute to try 4, 5, and 6. And then while you're doing that, I'm going to get the calculator ready and show you how to do these on the calculator. So after you do 4, 5, and 6, I'll give you a minute here, then we'll check our work with the calculator. So try 4, 5, and 6 right now. All right, so now how to do determinants on the calculator. So we can take, so if we're doing number 4 here on the right, all right, first we can just type in with the keypad DET. Oops, I'm in the wrong screen here. DET. So you can do it that way, and I'll show you another way. You just type in DET, then put an open parentheses, and then inside the parentheses, just put the matrix. So hit the button next to the 9, find the matrix button, and type it in. So 0, -1, 7, and 8. So if you got 7 for number 4, nice work. All right. Now, if you don't have a TI Inspire, but you do have a graphing calculator, like you have a TI-84 or TI-83, you can also do determinants on there. So try to figure it out. But if you can't, just ask. I could definitely show you how to do it. I just don't have the software on my computer to show you, but I could definitely walk you through it if you need it. All right. And then let's check our work for number 5. So remember, a beautiful thing about this calculator is you can copy and paste. So if you were doing another determinant, I would just arrow up, highlight that, hit enter, and then edit it. So change this to 1 divided by 3, change this to 2 divided by 3, change this to -6, change this to 3. All right, so for number 5, the determinant was 5. And then, one more time, copy and paste for number 6, keep that 1/3 there, change this to a 3, and then nothing else really changes there, 19. All right. Now I said there's another way to find determinant on the calculator. If you hit menu and you go to matrix, you can find all your operations for matrices right here. So you could also have hit that button, and then it would just come up DET parentheses, and you would just do it the same way anyway. So if you remember, you just type in the letters DET, and that would be the operation for the determinant. All right? All right, now for a 3 by 3. So there's 2 different ways you can do it. As long as you can do it by hand, either one of these ways, I don't mind. And I guess I'll just start with the more straightforward way. So the first way to find the determinant of a 3 by 3 is you take a row. So we're going to take the top row. And I usually just like to take the top row. But if you do have a row with a lot of zeros in it, then you want to use that row because zeros are nice, because anything times 0 is 0. So we're going to take the top row and we're going to circle one number at a time. So we'll start with 4. And then if you're in the top row, you kind of ignore anything in the column or row of that number. So anything in the column or row of 4, you ignore it for a moment. And then notice how there's like a remaining 4 numbers here. So we're going to take those numbers and then find the determinant of that matrix. So it goes +4. And then now you take the next number in that top row, so 2. You circle it. You don't have to circle it, but I find it nice to circle. All right, and now we're going to subtract, so it goes plus, minus, plus. We're going to subtract that number, so minus -2, times the determinant of the 2 by 2 of the remaining numbers here. So these 4 numbers create like a 2 by 2 matrix. So we would put a -3 there, a 1 there, a 2 there, and a -1 there. And we'll come back to that and we'll find that determinant. All right, and then erase this. All right, then do it again. So then take this last number. Now we're going to add that. And like I said, zeros, we love zeros when we're dealing with matrices because it means easy multiplication. So if this wasn't 0, then we would have to find the determinant of this leftover matrix here. -3, 10, 2, and 6. Okay, so now we have to evaluate that. So there's 3 things going on here that I just like to highlight before we move on to the next step. All right, the first thing is if you take the top row, it goes plus, minus, plus. Then the second thing that's happening is like these scalar multipliers come from the top row. So the top row is 4, negative 2, 0. So those are your scalar multipliers. And what are you multiplying that by? Well, once you pick one of those numbers, so if we look at 4, then you look at anything not in the column or row of that number, and those leftovers create a 2 by 2 matrix, and you want to find the determinant of that. All right, so now we're going to evaluate. So we'll do 4 times, is that a negative? Why is that? Oh, okay. 4 times, so 10 minus negative 1, or 10 times negative 1 is negative 10 minus 6. All right, so that's going to be 4 times negative 16. So that's going to be negative 64. Okay. Then for this part, that would be like a double negative. So that'd be like plus 2 times 3 minus 2. Negative 3 times negative 1 is 3. 2 times 1 is 2. Subtract them. So 2 times 1 is 2, because 3 minus 2 is 1. And then plus 0, because who cares what this determinant is? We're multiplying it by 0, so it's going to be 0 anyway. And you get negative 62, which you're like, why am I sitting in this class right now learning about this random thing? I promise you it has applications, but instead of trying to shove everything in one day, it's a Friday, let's take it easy. Let's just learn the basics of determinants, and next week we'll learn how to apply them and what they're used for. All right, so that's how you do by hand the determinant of a 3 by 3. All right, now the next method I think is a little more fun. It might be easier to remember. So I'll show you the other way. So the other way, oops, we lost it. All right, so for the other way, what we're going to do is we're going to take, I'm going to zoom in a little bit because I want more room for this. All right, so we're going to take the first 2 rows, or sorry, take that back, the first 2 columns. So this is column 1 here, and we're going to write it right next to this. And then take the other column, the second column, and like repeat it over here. Okay, then we're going to like multiply diagonally. I know this is really funky, but once you do it a couple times, you'll get the hang of it. So we got to multiply 3 numbers together. So we're going to take these 3 numbers and multiply them together. So 2 times 10 times 0 is just 0. And then take like these numbers here. 6 times 1 times 4. And that's going to be 24. And then do the same thing here. So you get negative 1 times negative 3 times negative 2. So that would be negative 6, because it's 3 negatives, so it's going to be a negative multiplied together. And 1 times 3 times 2 is 6. So that's negative 6. Okay? So you go like from right to left, and you kind of write the numbers right underneath. All right, so we'll add those up. And that's a negative 6, so that's going to be negative 18. Okay? Now, we're going to do a similar thing, but we're going to go in the opposite direction. So now we'll go from like the upper left corner and multiply these together. So 4 times 10 times negative 1 would be negative 40. I got a message here. Positive 18. Yeah, it would be. My fault. Thank you. 24 minus 6 is positive 18. My fault. Thank you. Good catch. All right. So go this direction now. So we get negative 40. All right. And then go this way here. So that's, I hope I'm not missing any negative signs here. That's a positive one. All right. So I guess I'm just going to erase these so I don't get confused with my signs here. So do, so we got this, sorry. So 4 times 10 times negative 1 is negative 40. Okay. And then negative 2 times 1 times 2 would be negative 4. And then 0 times negative 3 times 6 would be 0. Okay, add those together. And that's going to be a negative 44. Okay, and then what you do is you just subtract those two numbers. So 18 minus negative 44 would be 62, which is the same number that we got when we did it earlier. So that's another way of doing it. So take the first two columns, write them next to the right of the matrix, then multiply the three diagonal, like they each have three numbers in them. So multiply diagonally 3 times in one direction, 3 times in the other direction, and then subtract the two numbers. So that's another way of doing it. And then let's just see how you would find the determinant of the calculator. Well, just do the determinant, open parentheses, put a 3 by 3 in there, type in the numbers, and we should get negative 62 or positive 62, or else we did something wrong. But we get the same answer twice, so I'm pretty confident. Oh, it's negative 62. What the heck? We got negative 62 the first time. I'll have to look into that. All right, but that's how you do it. Did I put something wrong here? All right. So that's it. So why don't you try one of these right now. We'll go over it in a few minutes, and I'm going to look at what I possibly did wrong there. All right, so here's one more example of a determinant 3 by 3. Now, if you're watching this video, in the previous example, I subtracted them in the wrong order. So if we look at this problem here, all right, this determinant, all right, we want to take, if we start from the upper left and multiply diagonally from left to right, you take those three numbers, add them together, and then subtract it from when you go from the upper right. So when you start in the first row, third column, and go from right to left downward, you multiply those three together, or you get those three numbers, add them together, and then subtract. So the reason why I got the opposite of the correct answer in the previous example was I just subtracted them in the wrong order. So my apologies. Don't make that mistake. And always check with a calculator. All right, does anyone have any questions on this? All right, so last thing, just try some other types of problems with a 2 by 2. So the cool down. All right, so I'd like you to take a couple minutes, try these two, and let me know what you get. I'm going to pause my screen and then do it, and then we'll compare answers.